So now let's take a look what will happen when BJT is in active mode. So your BA junction must be forward bias. So here must be forward bias, and the BC junction must be reverse bias. So let's recall back how the electron and current flow happen. So electron flow will be always opposite with the current. So current will follow the whole flow. Now we would like to take a look what will happen to your electron and current flow during active mode. So at your active mode, so here we have N, P and N. So N is quite heavily doped. What does mean by heavily doped? Means there is a lot of carrier inside your N, which is the electron. P is very thin and lightly doped, and the other N it will be moderately doped. So here will be connected to your emitter, here will be connected to your base, and here will be connected to your collector. So between E to B, it will become forward bias. So forward bias means here is N, right? Negative, so here become minus, plus, minus, plus. So this is forward bias. What will happen at your BC junction will become reverse bias, means here is negative, here become plus, minus, plus, minus. So this is reverse bias. Now look back here. So N majority carrier here is heavily doped and it is electron. Electron and negative is repelling. So your electron here will move forward to your base. So at your base, since your base is very thin and lightly doped, so most of the electron will jump from your base towards your collector, around 98%. Only 2% will go through your base because this is very thin and lightly doped. And at your collector, what will happen? So most of the electron will comes here and will go to the attracted to your positive electron. So that's what will happen. Most of your electron will go from your emitter towards your collector. Now let's take a look what will happen to your current. Your current and electron is at your inverse direction. So since your electron is moving from your emitter to your collector, so your current will be at the positive opposite direction. So this will be IE. So since your electron will moving down 2%, so this will be your IB. And here will be your IC. Okay. So according to the KCL, you imagine this is your junction. So this is your IE. This is your IC. This is your IB. So IE equal IC plus IB. So this is the behavior of your NPN transistor is in the active mode. So now this is the explanation on how your current in the active happen in your active mode. Okay, so your emitter is at will be highly doped. So this is your emitter, as I explained before, highly doped. So when the emitter is highly doped, the electron will be repelled and then you can get your IE current. At your base, this is thin and lightly doped. So 2% will go through your base. The rest of 98% will go through to your collector. So this is what we call IB. And the remaining large number of electrons will accelerate to your collector. That's why we can get your IC. Okay, so now let's go through the analogy. So in this analogy, so at first, at your emitter is a forward bias. Okay, so at your forward bias, so we will have the potential must be much more larger than your VBE. So we can equate your VBE here like your turn on voltage means V gamma. So you know that at this is your base, this is your emitter, you have a diode right here. So the voltage here must be more than turn on voltage, that is V gamma, in order for this to turn on, right? So it must be higher than your VBE in order for the electron to flow. So when it is much more larger than your VBE, what will happen? Next, we will start to accelerate to the base. Since the base is thin and lightly doped, then it will go through the collector.